Welcome to the presentation of our paper, VRDFormer End-to-End Video Relation Detection with Transformer. Our collaborators come from the University of China. To begin with, we give an introduction of this task and our motivation. Our work focuses on video relation detection, which aims to detect all relation checklet instances in a video. Each instance is a triplet like subject, verb, object. Previous works addressed this task using a multi-stage pipeline, which mainly consists of four modules: object detection, object tracking, checklet pair generation, and relation classification. However, we suggest there are several limitations of such multi-stage pipeline. First, spatial temporal contexts are not well exploited in checklet pair generation stage. Second, each module is individually trained without any interaction, therefore they cannot promote each other. And finally, pair proposals are exhaustively generated to affect the performance. So considering this, we ask, can we design a unified end-to-end model to address above limitations? So we proposed VRDFormer. Let's focus on the object pair detection of individual frames first. VRDFormer has a video encoding module to encode the given video into a sequence of frame-level feature maps. The module consists of a CNN backbone and a multi-layer transformer. For each frame, we have n queries as input, and each query will predict an object pair, including their bounding boxes and classes. Such architecture is inspired by the recent vision transformer models like DETR. However, one question still remains. Since our target is the trajectory of object pairs in the video, so how can we effectively and efficiently track frame-level object pairs across time into checklet pairs? To achieve this, we split the query into two types. One is static query with fixed number, which is used to detect new object pairs in each frame and initialize new checklet pairs. Another is recurrent query with dynamic number, which inherit feature embeddings of an object pair from the previous frame and is used to expand existing checklet pairs. The whole framework is autoregressive. Finally, we have a transformer-based relation classifier. We keep every time-step query feature of each checklet pair as long-term memory. Using the memory, our model predicts the relation of checklet pairs using a transformer-based classifier. The training is multitask. One task is object pair detection. Given a pair of frames as input, we calculate the matching loss using bipartite matching like DETR. Another task is relation classification. We feed the model with a sequence of frames. The model predicts the relation of checklet pairs within these frames. Then, we use the cross-entropy loss for optimization. We evaluate VRDFormer on two benchmark datasets, including VRD-VRD and VRD-OR. Our model outperforms the state-of-the-art on both relation tagging and relation detection subtasks. And part of the evaluation study demonstrates the effectiveness of our VRDFormer. Here are some visualizations to show our model is able to use context for better category prediction and localization. Finally, as a summary, we proposed VRDFormer, a transformer-based end-to-end model. By first introducing the contextually enriched queries, we achieved significant improvement on video relation detection tasks. Thank you for listening.